Welcome back to Contextual Electronics. This is going to be a video kind of just showing off how I would create a tiny footprint. Tiny because, that's kind of the way that all footprints are going these days. And if you're going to find a new footprint package, you're probably going to move down into the smaller sizes. But I think there's a lot of value, moving away from just a, 1, 2, 3 step kind of teaching method to just showing you how I do it and talking you through the process. So let's take a look at that, and we'll just kind of learn as we go. All right, let's load up the KiCad launcher, and we're going to hop right into the PCB new, and then into the module editor. All right, and we can see we're centered. Now what we first need to do is actually find a part that we want to put in there. And to do that, we're going to go over to DigiKey and type in something like op-amp. See that we're tracking what we're looking at there. Go down to integrated circuits, and then how about linear amplifiers? All right, so these are all the, there's a lot of different amplifiers in here. You can see there's some standard package sizes. The thing is, standard packages are one of the best things out there because especially when there's standard footprints or pinouts rather, so if pin 1 is always the same across all the parts you use on an SOIC package or for an op-amp, then that's perfect because that's really the data that you need to know. That's the consistency you need from different vendors and different packages and everything. More likely, a more common task is going to be to actually you check out the footprint and the layout and the pinout of the packages you're planning on using, and you realize there might be a pin swapped, or it's just you need to check that kind of stuff as you drop these things in your design. A little bit less likely, but still definitely going to happen in most designs you do, it's going to be that you find a package that's not standard, right? It's going to be something that you're not used to, you've never seen before, and more importantly, one that you don't already have in your library. So let's try and find one that is unlikely to be in your library. And the other thing we're going to be looking for here is the fact that it actually has a footprint inside the PDF, just in the main datasheet PDF, because sometimes vendors put these off in separate documents and you can go find them and everything, but that's just a little boring and tough to find sometimes. I want to try and make sure we see something odd. You can see, a lot of these are non-standard parts. Not non-standard, but just a little bit less, less common, right? So an 8 SOIC, you're gonna have a lot of results there. But a 8 SON or 8 SON exposed pad, as you move into some more of these, you're gonna find less and less commonality among them, especially with pinouts. And sometimes it's advantageous to the vendors to actually have different pinouts, because then you design in their chip, maybe you like 1 or 2 specs of it, but then you design in their custom footprint, and then you're kind of stuck with them. I don't think it's necessarily malicious, but I think it is, it is based on patent portfolios and sometimes also characteristics of the circuits for isolation or random other things there. So let's see. Let's try. How about Micro 8? I have looked at this one once before, and it's a little odd. I'm not really sure why they go with this, but it is trademarked as well, so it kind of fits that mold of a vendor wants to have a very specific footprint. So let's take a look. We'll apply filters, and these are from Semiconductor. So let's try this op-amp here. So it's a rail-to-rail, pretty decent op-amp, LMV 932. I think I've used something in this family before. But, as you see more parts, they all start to look the same. So let's just make sure. I must have been looking at this once before. It went right to the page that I was hoping for. So we can see up top, this is, standard on Semiconductor. Here's some pictures of the footprints, SC70, TSOP5, and then Micro 8 is that one that we were looking at there. And SOIC 8 to kind of see the relative as well. All right, so let's go back down to the footprints. Now, normally footprint suggested package layouts are down at the bottom. I love it when they put the footprints inside the document here. Also, let's find, that's the SOIC 8. Let's go up to the micro 8. Here's a micro 8. So you can see they don't just specify the soldering footprint, which is very useful, but they also specify the physical dimensions, which is much more useful for when you're doing mechanical modeling, or you're trying to put in a 3D model into the Wings 3D program for KiCad, which we'll go into in future videos. So this stuff is all very useful, and especially the fact that it's listed as minimum, nominal, and maximum in both inches and millimeters. So it's that's a very good thing to have there. But this is what we're interested in. So let's in Windows, at least, it's gonna be Windows key and then hit the left arrow. That's gonna move that over to the right. And then in KiCad, left a Windows key and then right, and these are going to split the screen here. So let's pick a library to put this into. So let's put it into a non-standard library. Let's put it into let's see, Circuit Hub. Yeah, that's fine. I'm not sure if Circuit Hub would be happy with that, but that's one that is a non-standard. And then we're going to create a new footprint here, and we're going to call this Micro 8. And then I'm not going to try and put the trademark reference in there. Okay. All right. So we hit M to actually move this stuff around. Move this around. Move the value. All right. We are in business. So as you can see here on the soldering footprint, they actually do list everything from the center of the pad. So first thing we need to do is actually figure out what the pad size is. So let's see, down here it says it's millimeters over inches, so we're going to work in inches because I normally do, but you're welcome to work in millimeters as well. KiCad will take whatever you put in and then swap it around for you. So it is a 41 mil or thou high by 15 mil wide. So what we're going to do is go back over to KiCad, add a pad. We're going to click once to add a pad, and then we're going to mouse over it, hit E, and then this is going to pick up, bring up the properties section, and we'll actually start looking at this thing. All right, so first off, let's actually create the pad to be what we want it to look like. So we'll start with pad number 1, and then we're going to go SMD, because that's the this is a surface mount pad. You see the other options there. We're going to switch it to rectangular. And then let's see, so position we're going to leave alone for right now. You can see I put it right about at the center point, but not exactly. And then we're going to change size X to be 15. I'm going to change size Y to be 41. It looks like those numbers there were generated from what was formerly millimeters. All right. As we go down here, orientation's fine, offset's fine, pad length is fine. These aren't options for us. There's no drill here. That would happen if we switched over to a through hole, so we don't have to worry about that. And then we look at the layers here. So we're going to put on the top copper. We're going to also have paste setting on the same thing, and then solder mask setting, which is actually solder mask relief. So these two things, each time we put down a new pad, there will be a copper layer, there's going to be a paste layer, and then a solder mask layer. All right. Here we go. As we zoom in, we see it's not quite on the center point, but if we look at the relative, there we go. That's on center point. All right, so now we need to actually figure out which pins which. So let's zoom out of this document here. We can see this pin 1 ID is here, so at the bottom left, so we will keep this as pin 1. And then when you label pins, it's actually going to be 1, 2, 3, 4. Then you switch around to the side, 5, 6, 7, 8. And that's very, very important. Nothing will ruin your day more than going 1, 2, 3, 4, 5, 6, 7, 8. That is bad. You don't want to do that. So whenever you're labeling pins, you go down and then across, then back up. All right. So what we're going to do now, we have the first pin. Now what we need to know is the spacing. So we know that the spacing for, we know the size of the pad. Now we also need to know how far apart they are. And this is labeled just for that fact. So these things are 25.6 mils apart, and we are going to match that. All right, so let's hit the pad again. We're going to place, oops, I'm sorry, we're going to hit Control Z. So what we're going to do here is actually find the location here. Let's move it over. We're going to go try and down here, if you're looking at this, it's going to be dx is going to be 25.6 over. All right. Oh, that's going to be a little tight there. Now there's two things. One is that it's a little tight. If we actually placed a part, you can see it's overlapping. And it changed the pin number. We're going to hit Control Z again. Also, that the dimension here is 25.6 mils, which is, or thou. So that means we need to change the grid. So let's change the grid. It's at 1 mil. We need to make it 0.1 mil. Now, as you've watched in all the videos, grid is very, very important. You need to be careful about this. But we can look, since we placed the first pad right at 1,1, we can actually make sure that that we move it over the proper amount. All right, so we're going to do a 25.6. The key here is to make sure both, so 25.6 is on x, dy is at 0, and then this is the total distance. This is, it resolves the what is that, the hypotenuse of that, of whatever triangulation you create there. So make sure that's right. 25.6 and there we go. All right, now there is some overlap. So let's first off, let's relabel this to pin 2. Oops. All right. So pin 2 and pin 1 are placed. Now we can see there is some overlapping here, and this is because this is the clearance for the pad itself, and these are set at default right now. So if we mouse over pin 1, or pad 1 rather, if we go over to local clearance and settings, we can change this, but we need to be careful. This is about the pad's clearance, so it's all relative to what the size is, right? So if these are sized for normal SOIC pads, and we're creating really tiny pads, which we are, these are 15 mil wide pads. You know, I think a 30% margin or so should be fine. So let's switch this down to 5 mils. We'll change this to 5 as well. And then as we zoom out, we can see that has moved. All right, so let's do that for the other part. In fact, though, let's actually go to the global settings. Oh, sorry, that's not global. We go to properties. The global settings are here. We set 0 to use global, but this is actually going to set all of them on the page. So we're going to go to 5 and 5. All right. All right, so we've changed up that now. All right, so now we're going to actually just add more footprints. So in order to do this, though, we're going to just have a running calculator because, you know, even though it's only 25.6 mils, one away from another, you know, it's easy to key in a math mistake. We just want to make sure that's nice and easy. So I'm just going to open up Windows Calculator. You can do whatever program is good for you. So we're already 25.6 mils away plus 25.6. Next one's going to be 51.2. So let's hit this. We're going to go to 0 or 0.0512 512 and then y in the 0 direction. 51.2. I know I'm being a bit meticulous about this placement, but there is method behind the madness, namely that as, you know, if you want when you switch back to a larger grid size, you want to make sure it all lines up. So that's the real reason here. All right, and click. All right, that was the wrong. So we're going to edit that. Switch that to 3. All right, and then one more time, hit it equals again, 76.8. Just zoom right in. And 76.8. Oh no. Oh, that's right. As you hit edit, all that work for nothing there. As you hit edit, it actually stops the renumbering dialog. So we'll do this one more time here. 76.8. Alright. Enthralling videos, of course. Zooming in does help with the accuracy a little bit, especially as you're trying to hit specific marks. Alright, there we go. And the 4 is huge. Alright, so those. Now what we're going to do is move this across in the same amount. So it's going to be the same grid as over here. We're going to put it over in the x direction or in the y direction rather. It's going to be minus 0.167 or 167 mils. So let's see here. So we'll zoom in to minus, get a rough area here. Wow, that is really far apart. There's minus 167. Oh, 167. And at the same 76.8. 76.8. Oh, man. Hard to get this sometimes. 76.8. 167. There we go. There we go. And like I said, number, when you go across, it's 5. Alright, this one's going to be 51.2 and minus 167. Now we have a reference point there, so that helps a little bit. Minus 51.2 or 0.0152. 167. Bingo. Alright. And then 25.6. 6. There's a good one. And finally, we want to be on the origin 0, 0. 0, 167. And we'll zoom in. There we go, number 8. All right. So now the painful process is over. So we can move this up. So it actually, and actually, I usually don't like to have the package name on the final footprint once I drop it into the schematic or into the layout. So what I'm going to do is go to the edit window, switch this over to invisible, so it'll still show up in the drawing. You can see it's just a lighter color. Value, we're going to change this over. I usually like to use E or U rather. So because it's going to be used with parts that are ICs, usually I pick the prefix U. You can use whatever you want there. You can actually use IC star if you want, and then it'll, as it annotates the schematic, it'll actually put that in there. Now another thing we can do is we can add in drawings here, and so and this is actually another reason we can use our physical footprint up here, so we can see the body is D wide and E tall. So D is in inches 0.118, and E is, which E is that there? E, it's a square. All right, that's easier. So what we'll do is we'll set a reference point here, right about here, and then we're going to start 0.118 for both. Be able to verify that makes sense. 118 and 0. 118. There we go. And 0. Bingo. And this will be 118. 0.118. 0.118. 0.118. 118. Oops, not tall enough. Aha. Interesting. Okay, so showing what I did here is twofold. One is that it ends up looking diagonal actually. So I'm going to actually escape out of this, hit Control Z to get rid of that. So we're going to set this again. We'll actually set it on the origin. Oh, well, a little bit in actually. When we look back over here at the footprint, we see the footprint actually is, the entire amount that the pads want to contact. So usually there's a bit of overlap, as you see these legs curl down. So there will be a little bit of footprint in here. So let's actually kind of skew it inwards. Set that as our reference. Oops. Right about here. This is in the I set that too far. Let's just measure this to start with. So this to about here is right about it. So move it right a little closer. Eight. Almost there. Got it. This will be 118. They are listing that right on the edge there. I'm going to actually just outline a little bit wider. This won't be the exact outline of the package, but it really is just trying to notate where you want the package to go, more so than the exact size of it. So I lost what the original was there. One way to tell is that as you see this line kind of straighten out, it's not going to be a perfect measure, but it's a good way to eyeball. You can see it's pretty much straight there. And we know that our distance in the x direction is about right. So that should be good to eyeball, and then we go back to 0, 0. We should be good to go. And 0, 0. All right, so we have a package there, and now we're going to draw a circle to match this pin 1 ID, because that's really what's most useful here. That when you're placing a part, you want to know which pin is pin 1, especially if you're looking just at the silk screen. So let's leave that there. All right. So we have our micro 8 package. It'll be a letter U. And I think we're good to go. So now we're going to go save the module in the active library, which was the Circuit Hub library, because we didn't create a new one. Save it as micro 8. All right. And now we're going to go back to PCB new. Now this isn't going to be connected to a document or to a schematic at all, but we should be able to see it in here, listing all micro 8. There it is. All right. Wow, that is tiny. So it's for reference. This is a good idea too, just for having it for reference. Let's actually look and place an SOIC8 next to it. SOIC8. Nope. Nope. They listed as SO8. Sorry. Narrow, and that looks just about right. Aha. Now this reminds me of one thing that I probably did wrong here. That's actually a good lesson to teach. So I put the silk screen actually right through the pads. Now some fabs will be okay with that, but it's not the best. It's not the best idea. And you can see on the SO8 they actually don't cross through. And let's look at another example just to make sure here. But that is one thing that I neglected. I always like to have the actual package outline, or something approximating it. I could have just stopped and not put it through the pads, but some fab houses are gonna give you some grief about that. So let's go with a TSOP. TQFB 64 is fine. It's real big. Yeah, same kind of thing there. So not actually going through the copper. It's touching on the copper, but not going through. So let's quickly go back in, and we've already still have it up. What we can do is delete that line. Actually, we need to delete all of them. All right. Delete. We'll move this over. And I bet this will actually be closer to what the actual measurement is as well. All right. Oh, didn't reference it out. Yeah, that's much better. And we can just approximate this. with the silkscreen, it's not nearly as important as the actual pad, so that is a nice thing. Main thing here is trying to get straight lines. That's the main thing. Otherwise it looks a little wonky. And there we go. Ah, that's much better. Okay. So we'll save this. Close this up. Now, I think if we drop another one there, it actually might not show up. But we can see that it actually does maintain your old parts, so you first need to delete the module and then re-import it. And if we put in a new one, oops, we can see it did update. So that is how you create a very small package. You know, we could see these are some of the built-in ones, but hopefully you feel, after going through this, you can see it's a little bit more, hope you feel a little more comfortable actually creating your own packages. And definitely a good skill to practice and a good skill to have, because as you go through designs, it's going to be a very important thing. Thanks for watching.